So today we'll be discussing sameness relations, specifically relative identity and Leibniz's law, and how it relates to the Trinity, specifically the logical problem of the Trinity. And so the structure of this video is going to be very technical, so it'll probably be around 30 minutes or so long, hopefully shorter. But it's going to be in stages. So the first stage is going to be what is Leibniz's law and what is relative identity, what qualifies as a sameness relation. The second part of the video is going to be, does relative identity solve the logical problem of the Trinity? And the third part of the video is going to be, why would we accept relative identity instead of using Leibniz's law? Because there's a lot of objections to relative identity being ad hoc. Some people, or many people, argue that it's only used in theological contexts, which I think is incorrect, and we're going to talk about that. And then the fourth and last topic is we're going to discuss whether or not Leibniz's law can be considered classical. Can it be considered the default? So the first thing is, the entirety of this is us talking about sameness relations. So we say X equals Y. And it's important to understand that when we say X equals Y, we are not necessitating as a default Leibniz's law. Okay? Leibniz's law is a specific clarification and interpretation of what it means for X to equal Y. But all that's required for a sameness relation, X equals Y, are these three principles here: reflexivity, symmetry, intransitivity. So you can just think of, these are the formal, and it's just so if you guys want to pause it and copy and paste it and put it into, I don't know, like Google or something, and see the formalized version, I put it there for you guys. But reflexivity is just saying A is identical to itself, basically, is what it's saying. If you have A and you have an equal and you put A, you could swap them, right? And symmetry is saying that if X is equal to Y, then Y is equal to X. And transitivity is probably the one you're most familiar with. Basically, it's saying that if A is identical to B, B is identical to C, then A is identical to C. And so it's important to remember that, and this is a very common misconception, because people will say that X being equal to Y implies that all the predicates are identical, but that is not necessitated. That is a specific interpretation of what a sameness relation is. It's people trying to clarify how we predicate towards sameness relations. And so let's clarify, what is Leibniz's law? Well, Leibniz's law is stating that if X is identical to Y, then they must share all the same properties, right? So it's not just stating, it has to satisfy these conditions of reflexivity, symmetry, and transitivity, which it does, but it's not just stating that, it's stating something stronger, much stronger. It's stating that if X and Y are identical, then they must share all the same properties. Relative identity is stating that X and Y are, when we say X and Y are identical, it's always in reference to a kind, an F. So we'll write it like this: X is the same F as Y. So we index it to a sortal category. And a sortal is just something that's countable. So you can think about it being indexed to something that's countable, like a person, a human, a god, a tree, a chair. It does not have to be a category, because particulars are countable. And so you can think of this as making a weaker assertion than Leibniz's law. And so it's important to understand, again, that a sameness relation is just these three. That's the only thing that's entailed when we're talking about sameness relations. Okay. Now, when we say that, there's a question to which of these should we use, and there arguably are other forms of predication, but this video is primarily about the theological dispute around the Trinity, so we're going to focus on these two because they're probably the most common forms of predication. And so it's crucial to understand that the discussion that we're having is which one should we use. There's none of these are by default. Okay. So now that we got that out of the way, let's talk about what the logical problem of the Trinity is. Okay, so the logical problem of the Trinity, what is it? So it's fairly popular, so you should have a decent idea of what it is if you're watching this video and you searched it up. Basically, it says this. It says that using Leibniz's law, if F, the Father, is identical to God, the Son is identical to God, absolutely identical, and the Holy Spirit is identical to God, then following the law of transitivity, if A is equal to B and B is equal to C, then A is equal to C, then if the Father is equal to God and the Son is equal to God, then following the law of transitivity and equivalence relations, then the Father should be identical to the Son. And this logically follows. So then it creates a contradiction, right? Because we're saying that the Son is not identical to the Father, but using absolute identity, it necessitates that all the predicates are identical. So you cannot distinguish from person in essence, in this sense, because when you put in a sameness relation under absolute identity, it's counting, as we talked about, all the predicates, because it's only the same if it counts all the predicates, which means that following the law of transitivity, the Son is identical to the Father. So there's a formal contradiction, P and not P. So I haven't seen any way to resolve this using absolute identity without using a non-classical logic. And so let's look at relative identity. So relative identity, as we said earlier, it's saying that when we make a sameness relation, we can never say X and Y are the same simpliciter. So relative identity theorists, like Peter Geach, says that's just a meaningless statement. So what we say is the Father is the same God as the Son. The Father is the same God as the Holy Spirit. But because we reject Leibniz's law and we don't consider sameness relations to be necessitating all predicates, that means that we can distinguish that the Father is not identical to the Son in person. The Father is not identical to the Holy Spirit in person, which preserves transitivity because the predicate God is transitive. This is the formulation. This is the formulation of symmetry, reflexivity, and transitivity using relative identity. And the little underscore is how we show that we're indexing it to a kind. So we're saying the kind of whatever, the kind of F of whatever. So it preserves all of the equivalence relations. And then there's no longer a formal contradiction because you can now say that the Father is identical to the Son in respect to his divine essence. Or you can say that the Father is identical to the Son or identical to the Holy Spirit in respect to divine essence, but not identical in person. So now you've eliminated the formal contradiction. So there is no, just to answer very clearly, there is no contradiction using relative identity. And most of the objections that you will get when you use relative identity have nothing to do with there being a formal contradiction. It has to do with people questioning whether or not we should even use relative identity, whether it's ad hoc or whether it's subsumed under absolute identity, and whether the church fathers held to this form of predication. It has to do with a bunch of other objections, but most people today will say that if you lose relative identity, there is no formal contradiction. There are just other issues, and we're going to get to those issues next when we compare the two forms of predication. We're going to talk about why, outside of theology and outside of the Trinity, why you should accept relative identity and not accept Leibniz's law. Again, this is outside of the Trinity, but we're going to use the Trinity as an example because that's where I see these debates are most commonly had, are in theological circles. Usually, anti-Trinitarians arguing against the Trinity argue that we need to use relative identity. Okay, so now we're going to talk about some of the reasons why we would accept relative identity and reject absolute identity. So the first problem with relative identity has to do with vague concepts and the loss of meaning. So let's take a couple examples. The classic example is, I think I'm pronouncing it right, the Sorites paradox, which has to do with the issue of when a hump of sand, or when a couple grains of sand become a hump of sand. To think about it visually, think about having a pile of sand in your hand, and it's recognizable as a hump of sand. But then one by one, we start removing pieces of sand, and we're trying to figure out at what point does it become no longer a hump of sand. Okay, so this is the classic example. Someone comes up to two piles of sand, and they say, wow, those piles of sand are the same, right? And they're clearly talking about the amount of sand. And so when they say they're the same, according to Leibniz's law, they're required to say sameness relations equals all the same predicates, which means that Leibniz's law is going to require you to define how many pieces of sand there are in order for there to be a true sameness relation. And the argument is that in natural language, there's going to be a loss of meaning if we do that, if we apply Leibniz's law here. So if I'm coming up to someone and I say, wow, those two piles of sand are the same, and then you say, well, how many pieces of sand is required for there to be a sameness relation there? Right? Now you're asking me to restrict the scope of what it means for there to be two piles of sand that are identical. And there's a question there about whether I meant that initially or didn't, right? Now just think about this practically. If you're going up to two piles of sand or two piles of snow, right, or two houses, and you say, well, those are the same house, they're the same size. And then someone asks you, well, to say they're the same size, right, the same size house is to say that they share all the same predicates, right? So whatever size of house that you're accounting for, let's measure it and let's see if they're actually the same. And obviously, you're not going to have, I mean, conceptually you can, but in going up to a beach, you're not going to have two piles of sand that are identical in terms of the exact number of grains of sand. So the person clearly, if they're forced to define how many pieces of sand are in the grains or in the hump, that's clearly not what they originally meant, which shows that we often in ordinary language use sameness relations, or we don't in our minds when we meant it originally have in mind the exact amount that equalizes it, yet we're able to identify and make sameness relations in reality. And people will argue that, well, this is just an epistemic issue, that we just don't know the amount of sand, right? But the idea of a vague concept isn't an epistemic issue. It's in the concept of the heap of sand, which is why it causes a problem. The idea is when we say there's a heap of sand, do we have an exact amount in mind? And if you think about it practically, no. If it's no, then it's the concept itself that is vague, because it becomes difficult to distinguish when a lot becomes a little, becomes kind of. And that's why alternative forms of logic were even created to satisfy a range of truth conditions, right? Like think about fuzzy logic. Let's use another practical example. Two people come up to each other and they say, wow, we both have a lot of hair, right? We both have the same amount of hair. Now, this is something we can think of as very practical, and it would happen in real life, right? You come up to someone, you say, wow, I also have a lot of cars, right? Now the question is, when we make that sameness relation, is the concept itself of having a lot of cars, is that itself a vague concept? Because if you're adhering to Leibniz's law, then you're saying the sameness relation, in order for it to be true, they have to have all the same predicates, which means you have to have the exact number of cars. So if it's false if you don't have the exact number of cars. But if I go up to my friend and I say, and let's imagine I have 8 cars and he has 10 cars, and I'm like, and I didn't know he had that many amount of cars, and I'm like, wow, you also have a lot of cars, right? I'm saying there's a sameness relation between cars, but am I specifying an exact number in my head? Obviously not. And that's how we speak all the time. It's how we speak conventionally. And the point about rejecting Leibniz's law here is that Leibniz's law cannot account for this. It forces you to determine an exact amount of cars. When in everyday language, when we make sameness relations, overwhelmingly, we don't have an exact amount in our mind. And the question is, if we specify it, do we lose meaning from the original concept we had in mind? And I think that's an obvious yes, because the person wasn't sitting around thinking, wow, there's a threshold for when I'm hitting a lot of cars, and then there's a threshold for when I don't have a lot of cars. You know, maybe it's 6 cars. Someone has a lot of cars at 6 cars. And no, obviously they're not thinking that. And if you ask them about what is a lot of cars, it would differ among a lot of people. Not because there's an epistemic issue there, but because the concept itself differs. It's a vague concept in principle. It is not something that has strict definitions. And if you argue that it does need a strict definition, that's a much stronger ontological commitment that we're going to talk about after the vague concept. And you're going to fall into violating Occam's razor, is what I will argue. But the question is, do we give it a definition, a strict definition, outside of our sort of colloquial understanding of these concepts? And if we do give it a strict definition, does it lose meaning? If Charlie tells Sarah, wow, me and you both have a lot of hair, there's an equivalence relation between hair, are we required to specify how many pieces of hair? If not, if we can admit that it may be a range that is susceptible to change and there's no strict amount, then that means that these concepts aren't limited by a strict set of predicates. If they're not, then this violates Leibniz's law, because Leibniz's law states sameness relations require all identical predicates. All. In principle, all identical predicates. That doesn't mean necessarily we know them all, right? It just means in principle, that's what a sameness relation is. And the argument is that the concept of a lot, for one example, in itself is vague, right? Think about just ordinary things that they're just extremely hard to define. Like think about a car. I mean, when we say, oh, we both have cars. We have the same car. I mean, are we saying that it has all the same predicates? Obviously not. And if we try to limit the scope of what a car is to a set of predicates, it's very difficult. And the point is, it's very difficult, and we're not going to assume that there are a strict set of predicates that can make it identical to itself. So just something to think about. It's one of my favorite examples because I openly accept vague concepts. I think that most people would accept vague concepts if you explain it to them accurately, especially with analogical expression. Think about, we're not talking about meaning being univocal or equivocal. Univocal meaning it's the same sense, equivocal meaning two distinct or more senses. Analogical meaning that by analogy we produce a meaning, right? We produce a sameness relation, but that means that it's not reducible to a strict set of predicates because it's by analogy. And that we can get into that later about how analogy in itself creates vagueness where you cannot limit its scope to a set of necessary and sufficient conditions. That's why it's analogical. Now that we talked about how there's a loss of meaning in specific vague concepts, we're going to talk about what Leibniz's law commits you to, because at first glance it seems like a very intuitive law, and it doesn't seem like it carries any commitments that you wouldn't want to take on. But here I'm going to argue that it takes massive commitments and ignores entire fields of philosophy in order to establish itself. So the core argument is that Leibniz's law is inflating ontology. It is getting you to commit to beliefs about objects themselves that I'm arguing are completely unnecessary. If we hold to relative identity, we don't have to do this. So this is what Leibniz's law forces you to do, these first three steps. So it forces you to list every possible predicate when comparing two things, right? Because what we want to say in Leibniz's law, as the formulation goes, is that X and Y are identical if they share all the same predicates. So you have to be able to list every possible predicate in order to figure out if they are identical. And they force you to fix the predicate's meaning. The predicates aren't able to be vague in themselves, right? If there's a shift of meaning, then there's a vague concept in itself, and then that shifts the idea that all the predicates are identical, because then there's a question of is there a variety of truth values to each predicate? If there is so, then it has to be clarified in absolute identity. And then the third is that it only accepts complete total sameness. So think about what this is saying. It's saying that for any objects that are said to be the same, they have to be totally complete. Now that they're saying that about every single object, in the form of it has to be able to be predicated towards in sameness relations, and it has to be able to be clear. The meaning has to be fixed, right? So I can't say we're the same height, but then I can't tell you, are we each 6 foot? Are we each 5'5"? I say, well, I'm not sure. Well, then Leibniz's law fails, right? Because there has to be all clearly laid out predicates. Otherwise, we fall into issues of vagueness, and then you would have to come up with other forms of accounting for those truth values. Are they the same? Well, you can't say, I don't know in principle, or else it breaks down the idea of being able to strictly predicate those sameness relations. And so what it forces you to do is reject things like family resemblance. And when I say reject things like family resemblance, I'm not talking about in an epistemic sense. I'm talking about in the sense that Wittgenstein said, where in principle, there are concepts like family that do not have necessary nor sufficient conditions. And what that means is that we can identify a set list of predicates that equalize them. So by committing yourself to absolute identity, you are rejecting that view. And so you're taking on something about all sameness relations, right? Just think about that. How many sameness relations do we use in ordinary language? You're committing yourself to every single one of those sameness relations, saying that there are, in principle, in the concept itself, it cannot be a family resemblance concept. What about Derrida? Derrida is probably the most radical of all of the people you can think of. where he argues that meaning is never fixed, it's never stable, it is never able to be strictly defined. It's always shifting. And then that goes into his concept of difference, where meaning is always deferred and differentiated. And so are we just going to act like he doesn't exist? Is there no engagement? Why do we accept this extraordinarily strict commitment? What's the reason? Is because it's not as flexible as relative identity. Relative identity won't commit you to a universal claim about all predicates, right? It's not saying that we have to believe, we have to lay out for every concept and every sameness relation all the predicates clearly defined. Relative identity can accept vague concepts because it doesn't force you to identify the predicates, all the predicates in the sameness relations. What about Heidegger? Heidegger, with his critique of present at handness, argued that predication is a secondary form of how we're aware of objects, and it's a derivative form of how we are aware of objects. He argued with his concept of being in the world, and there's like a primordial understanding of being, a way of our everydayness, of operating with being and objects. Before we objectify them into the assertion form, the predicate form, we have an understanding of them in how they reveal themselves to us that is not reducible to predicate forms. And for a lot of people who are into analytic philosophy, I know it's going to be harder to understand Heidegger because he's like the staple of continental philosophy. And so I would read into Heidegger because, he influenced the entire tradition, where he showed that metaphysics was stuck in that predicate form. It couldn't move beyond that. And he was thought to have moved beyond that and shown a more primordial understanding of being and sameness, that accounts for sameness relations. So why would we inflate our ontology, just take on this drastic commitment about rejecting vagueness in principle, saying that every single concept must have an identifiable list of predicates in order for it to be the same? Why? Now, this doesn't mean that in terms of the sameness relations, do we have to account for, does the other sameness relations not have to account for reflexivity, symmetry, transitivity? That's a separate question. The question right now is about whether or not we have to take on this commitment, because relative identity can deal with reflexivity, transitivity, symmetry. It does deal with that, as we talked about earlier, and we're able to formalize it and show that. But the point is that you're taking on a massive commitment. Why would you do that? And I have yet to hear someone explain to me why I have to list every possible predicate, why I have to take that commitment on when I want to identify a sameness relation, and why I have to assume the implication is that objects in themselves have a set of identifiable predicates. And this goes into another point, is that, and this isn't necessitated, but this is implied by absolute identity, is that objects, there's an external world, and we have the object is identical to itself in a fixed manner to where we can identify the object and uncover its total list of predicates, right? Think about what happens if you don't accept that. Think about if you take more of a conceptualist viewpoint and you believe that it's our mind categorizing things and there is no fixed set of predicates outside of our limiting the scope of those predicates. If that's true, if we are just limiting the scope of our predicates arbitrarily, or maybe as Kant said, our mind, and we have certain intuitions that do that for us, we're not consciously doing it, think about what that does. Does that not move us closer towards relative identity? Now, remember, I'm not saying that it necessitates relative identity, but I'm saying it seems to apply a much weaker form of absolute identity. Because if we're saying that our mind is limiting the scope of the predicates applied to any concept, then it becomes more ambiguous about why there wouldn't be vague concepts. Because then, according to most views of conceptualism, the universal or the particular that we're predicating towards is in part appearing to us, and we're predicating towards something that isn't the object itself. It may have a ground in reality, which is what most conceptualists' views take, but we aren't predicating towards the object itself, which brings us to the question of, well, what is stopping it from being a vague concept? What if we can only have access to concepts that are vague in principle, that their meaning is shifting and unstable? If that's true, then that strongly undermines absolute identity, because it relies on fixed predicates. It doesn't allow for predicates to change and shift. It has to be A and B. They share X. X is defined. It's not shifting. It's not unstable. And we're forced to define it. We're forced to find out which predicate it is, and it can't be vague. But think about what that commits you to. I mean, you're forced towards really a stronger form of realism, unless you want to start weakening your idea of Leibniz's law and then get pushed towards saying, well, sameness relations are really conceptual, right? They're, in a sense, a product of our mind. And if they're a product of our mind, then we have to think about us moving towards the position that they may be vague in themselves. And we have to move towards, if that's the case, then we have to justify why every single concept would have to be strictly defined. And I have yet to see the justification of that. And that seems like a huge gap to bridge if you're going to take on that commitment. Now, remember, I'm not saying it forces you towards relative identity. I'm saying that it seems to push you towards a more contextual form of predication, where a very strict absolute identity theorist seems like they would want to say, well, there just are objects, whether we identify them or not. There just happen to be objects. There just are objects. And then we have to do the work of uncovering the predicates. But the reason there are sameness relations is because there just are objects that are the same in reality. Maybe think about an abstract object like 2, and then we have multiple counts of 2. And you can think about that like, well, there just are abstract objects. It makes sense to hold Leibniz's law if that's true. But that seems like it brings so much baggage of realism into the picture. So in conclusion, that I don't want to take on those unnecessary ontological commitments. And I have yet to see someone just... Okay, so I got kicked out of my room because I ran out of time in the library, so we'll be out here now with the beautiful view behind me, talking about the last aspect of why we should reject absolute identity, and it has to do with quantum mechanics. So in quantum mechanics, there is something called the Bose-Einstein statistics, and the fundamental aspect of it, like it doesn't work without it, is the indistinguishability of particles. So what does that mean? That means that two particles aren't identified by their individual identities, but rather by probabilistic wavelengths, or wave functions, sorry. Now, what exactly does that mean? That means that, well, think about it like this. If we have two balls, I have ball 1 over here and ball 2 over here, and I swap them, the configuration has changed, right? Let's say the configuration is the system. But in quantum mechanics, when we have two particles, we have one here, we have one there, and we swap them, the configuration doesn't change, right? But according to Leibniz's law, it should change. I'm not going to get super deep into what exactly that means, but if you're interested in it, in verifying what I'm saying, look up Bose-Einstein statistics. It is overwhelmingly accepted by physicists. Overwhelmingly. You will not easily find a physicist who disagrees with quantum mechanics and Bose-Einstein statistics. I mean, we have tests, experiments that have verified this stuff. So it's not something where you can write it off and say, well, that's just one interpretation. Quantum mechanics is one interpretation. It is an overwhelmingly accepted idea. And we can formulate this in a syllogism. So we can say this. Premise one. If Leibniz's law holds, then swapping two particles should change the system. Swapping two particles does not change the system, therefore Leibniz's law does not hold. Now this is true in quantum mechanics. In the wave function, when you have a particle 1 and particle 2, and we swap them, the wave function does not change. The system as a totality, it does not change. Now think about the example that I gave you. The configuration should change according to Leibniz's law, because all of the predicates are identical, yet we've swapped their positions. So it is unilaterally accepted that absolute identity breaks down in these instances. That doesn't mean that absolute identity isn't used sometimes in quantum mechanics. It is. It is used sometimes. Now, but what this goes to show is that the principle of Leibniz's law does not hold universally. It starts breaking down empirically, verifiably, when we get to the level of quantum states. And so hopefully you can verify exactly what I'm saying. Google it, because it's really mind-bending to think about, well, how can things have all the same predicates, all the same properties, but not be identical? I mean, they don't change the system when you swap them. Well, it happens. You know, lots of things that are hard to understand or seemingly unintuitive at first happen, like time dilation. If you were to ask someone before we figured that out, you know, like about time dilation, they would look at you crazy. But because of the fact that we have empirical observations, verifiable tests, and it's so overwhelming, no one denies it anymore. I mean, or no one, overwhelmingly it's held, and no one who's taking seriously denies it anymore. So that ends this video on relative identity. I just want to conclude with this. If you have any questions, any objections, please comment them. Please, I mean, I want to hear it. I would love to have to reevaluate my position on this. I mean, it gets me excited to think about the fact that I could be wrong, because I am this is one of the things that I believe that I am super confident about, that we shouldn't accept Leibniz's law universally. But it would be interesting to see someone posits that, because there are deeper implications about Leibniz's law, like why Heidegger rejects it, or why Deleuze rejects it, why Derrida rejects it, which I'm more in the continental aspect of philosophy, postmodern philosophy. So I'm interested in seeing a defense of Leibniz's law, but I think that the reasons that I gave are sufficient for rejecting it today. But please, comment what you think, comment your objections, comment any point of clarification that you would want. If I can't clarify it in the comments section, then I will likely make an entire video about it, clarifying it, if it's something that needs that. But that's something that I want to do. So please, like, subscribe if you want more niche content, more technical content. If you think that I wasn't technical enough, just let me know and I can improve. Thank you.